Next up is Dan. Dan works at Facebook and is the co-creator of something called GraphQL. How many people here have heard of GraphQL? Okay, how many people here actually use it in production? Perfect. Okay, good. So everyone knows it, and Dan is going to come up here and convince you to use it and teach you how. And that sound all right? Okay, here's Dan.
Clicker. 1 second, I'm going to retrieve the clicker. This triangle demo, by the way, is amazing. And if you get the chance to talk to anyone for README, ask them the story of how the triangle demo happened this morning. It's great. There was a lot more to it than they let on in that demo. So my name's Dan Schafer. I'm a software engineer at Facebook. I've been at Facebook for about 7 years now. I spent the first 2 years on the newsfeed team. And then about 5 years ago, I started working on a new newsfeed API for Facebook. And that eventually emerged into the project that became GraphQL. And so I've been working on GraphQL for about the last 5 years now. We already did the show of hands. It sounds like a lot of people are familiar with GraphQL. I bet a lot more of them are familiar now that we had Calvin's talk this morning. He gave a brief overview of it. I want to dive into a little bit more detail to start, just to make sure everyone has, I guess, surface level familiarity with it. So this in Facebook's API is the hello world of GraphQL. It tragically does not return hello world. Instead, it asks for the current logged in user. That's that me field that we see. And then it asks for the current logged in user's name. So if we're logged in as me and we run this, we unsurprisingly get my name. And already you can see in GraphQL some of sort of the core tenets of it, where the response that we got on the right is in JSON, but it matches structurally the query on the left. All of the things that are keys in our JSON response were what we call fields in GraphQL. And this is the key principle because it allows us to be very predictable to our clients. They know exactly what data they're going to get back, and in particular, they can customize what they want to get back. Let's say I don't just want to render the currently logged in user's name, but I also want to render their profile picture. Well, I'll change the query here, and you can see here we're using some nesting. Profile picture isn't a scalar-like name, which was a string. It's instead an image, which has a width, a height, and a URL. And ideally, just having seen that first slide, you can already guess what the shape of the JSON response is going to be. All of the fields become keys. All of the sort of low-level fields become values, and the rest become nested objects. And you can see we fetch the width and the height and the URL. And this becomes even more compelling when we start thinking about pagination. We start thinking about situations like was described earlier with that Slack list where we wanted to show not just the channel, but all of the people and some facts about them. GraphQL allows us to really easily solve what we call the n+1 problem. You don't have to do one round trip for a list of the things and then n more round trips to get details. Instead, if I wanted to get my name and birthday and then a list of my teammates' names and birthdays, I would issue this nested GraphQL query, and I would get this response back. And you can see I fetched all the data that I need to render this paginated list all in one round trip. And I also have an overfetch. There's a lot more information about a user than just name and birthday, but that's all I need for this demo, and so that's all I'm going to end up using. One final principle of GraphQL that we have is some means of basically composing GraphQL queries. You can imagine that as you're building more and more complex UIs, you end up in a situation where it's really hard to manage, and you want a primitive like a view in a view hierarchy or a function in programming. And so we have these fragments where we can reuse them. We can say this fragment of basic info has name and birthday, and I want to fetch that not just for me, but also for my teammates. And if you're interested in trying out GraphQL, if you haven't used it before, there are a couple of companies that have launched betas of public GraphQL APIs. GitHub is one of them. You can see I went to GitHub's API and queried for the GraphQL.js repo. I asked for its name, and I asked for how many people have started. Thank you to those 6,400 people. And one interesting thing I want to point out here is this is a web app. This is something that we have called Graphical. And what was talked about this morning really resonated with me about how we want a delightful experience for our developers. And that I think is what Graphical provides, because you end up on the left, you can't see it here because it's a slide, I'm not doing a live demo, but it has a type ahead. As you're typing, you can see all of the available things, and so if you go to an unfamiliar API, I had never used Yelp's GraphQL API, but I saw that they announced it, and I wanted to get information about the Folsom Street Foundry, and you just start typing something like location, and it says, oh yeah, there's a location field, and oh, by the way, it's not a scalar, it has an address, and it has a city, and it has a state. And this is all powered through introspection. GraphQL can answer questions about what it can do. This is very similar to the HTTP options that Amanda mentioned, where we can say this is all of the data that we have available. These are all the types. These are all the fields. And that makes it really easy to do something like code gen. Our iOS and Android clients all use GraphQL, and they use introspection to use code gen in a similar manner to what Calvin described. So that was a whirlwind tour of GraphQL. There is a lot more information on GraphQL.org. There are libraries in all sorts of different languages. Basically you name it, there's probably a GraphQL library there. Has a list of companies that are already using it. If you're interested in learning a lot more detail about GraphQL, I recommend checking it out. So this is the part where I could do the, rah, rah, everyone should be using GraphQL section of the talk. It's the future. There was a hilarious tweet I saw earlier where it was, the checklist of things you're going to hear at API conferences, and one of them is GraphQL is the future. If you're hoping to check that off your bingo card, it's actually not going to happen in this talk. Because rather than talk about GraphQL and why you should use it, I want to answer some of the questions that I've gotten from people who are trying to build out GraphQL APIs. Because they almost always have a similar set of questions. They're going to ask, okay, I'm convinced to use GraphQL, but how do I implement authorization? How do I make my API efficient? You just described the ability for the client to customize what data it's going to fetch. How do I then make that efficient on my server? How do I go about caching my results, which is a hard problem both on the server for efficiency and also on the client because you don't want to be refetching data. And I was looking at these questions, and I realized this doesn't have anything to do with GraphQL at all. This is a general problem that we have when building APIs, authorization, efficiency, caching. And so I'll talk about it today in the context of GraphQL, but I think the ideas, these questions, the principles that let us solve them are relevant beyond just GraphQL. They're relevant to all API building. And so I'm going to talk about it in the context of Facebook's GraphQL stack and how we solve these problems. And in particular, the way that we solve these problems really boiled down to 3 key principles. And I think one of them boils back to that original war room where we're building out GraphQL for our iOS client, and we had no idea what they were going to need. We could not anticipate what they were going to try and build in that initial version 1. We couldn't know what they were going to take out, what they were going to bring in. There was no way for us to build an endpoint for them. We just couldn't do it. It was constantly changing. We would constantly be behind. But we knew about the Facebook graph. We knew that there were users on Facebook. We knew that users had friends. We knew that there were events, and events had attendees, and there were groups. And so whenever we thought about our API, we tried not to think in terms of endpoints. We instead wanted to think in terms of graphs. And the thing that GraphQL then let us do is effectively allow the client to define a dynamic endpoint anytime they wanted to change what data they wanted to fetch. The second thing that we really strived to do was to have a single source of truth. When I think about questions like authorization, you really don't want to mess authorization up. That is not something you want to mess around with. And so writing it down in 2 places just increases the chance that you're going to get it wrong in one of them. And so we wanted to make sure that critical things like efficiency to make sure that our web stack was going to hold up, like authorization, was located in one place and that we could rely on it. And finally, we wanted to have a thin API layer. And I think this ended up being both a constraint that was placed on us at the time because we were developing GraphQL really as an ad hoc. It was an experiment. No one had any idea if it was going to ship. But it's become a really core principle as to how GraphQL works at Facebook because we don't just have a GraphQL API. Our iOS and our Android apps use GraphQL to fetch all their data, but our website is still predominantly server-side rendered, so it actually needs an in PHP or in hack language API to fetch its data. We still have a REST API. I have no idea if we've deprecated FQL at this point. I hope so, but we still had that for a while. And so we really wanted our API layer to be thin because anything that we put inside GraphQL, we were probably violating that single source of truth principle I had on the previous slide. And so I'm going to describe how we've implemented Facebook's GraphQL stack, but I think those 3 principles and how we applied them to GraphQL are hopefully relevant to other APIs. And I'm actually not going to use the Facebook context to describe it. I'm going to describe a custom app that we're going to be building. And the first thing we're going to want to build in this custom app is authorization. And I didn't have pizza or snacks or anything quite that clever, so instead we're just going to use good old to-do MVC. We want to build to-do MVC app, and we want to add authorization. And so our authorization principle is probably going to be pretty straightforward. What's the simplest one we can think of? A to-do item can only be seen by its creator. That sounds good. We're going to have multiple people using this app. You shouldn't be able to look at my to-dos. I shouldn't be able to look at yours. Okay. Well, what's a to-do item? In order to answer that authorization question, in order to implement it, we have to have some sense of what a to-do item is, and there are a lot of different answers that we could have here. One thing is it might be a REST resource. We might say a to-do item is this particular URL and the resource that it represents, but I would argue that that's too specific. I would argue that we don't want to say a to-do item is only this REST resource because our authorization policy should apply whether we're using REST or whether we're fetching it on the server or whether we're using GraphQL. So I would argue this is sort of too high in the stack. I'm actually going to recreate the Goldilocks analogy inadvertently here. Because we could also go, I'm spoiling it here, too low in the stack and say, well, it's the command that we issue on our SQL database in order to fetch that to-do item. But that has issues too, because what if we decide we want to stop using SQL for whatever reason? What if we're just going to switch over to some sort of point storage where there's just going to be a key for it? Right? Putting the authorization or thinking about our to-do item in terms of how it was implemented restricts us because it prevents us from moving storage without having to completely rethink how our entire app works. And so you can imagine that the diagram and sort of the facade I just described assumed our stack looked like this. We had our external interfaces like REST or GraphQL, and we had the storage layer like SQL or Redis or wherever our data was, and there was nothing in between. And certainly in Facebook Stack, that's not the case. We instead have business logic in between. And this is where the heart of the app lives. This is where really all of the smarts in the stack are. And in particular, at Facebook Stack, it looks far more like this, where the GraphQL API is thin on top, and the business logic is really the meat of it. And I actually show a slide almost identical to this when I'm teaching new engineers at Facebook about GraphQL. And like the box is that small. We really don't think of this as being a thick piece of the stack that's responsible for a lot. All right, I dodged the question. What's a to-do item? I said a lot of things that it was. I said a lot of things that it wasn't. And the honest answer is there's no hard and fast answer. But for the purposes of this talk, and this actually matches what we do at Facebook, it's this. That's really boring. It's just an ES6 class. It's got some properties. It has a constructor. But it gives us something that we can use. And I promise, even though I'm using ES6 classes here, this isn't going to end up being a talk on object-oriented programming and its joys. I'm not going to show UML diagrams, but other than that one. But we are going to have this class. And the key part of this class is that it's our single source of truth. This is where all of our logic is going to live. And as this talk progresses, all of those questions that we had about authorization, about caching, about efficiency, we can put them all in here. Because that way, no matter who's consuming it, what API is consuming it, we have answers to all those questions. And no matter how our storage works, the storage is completely abstracted underneath this single source of truth, this thing that is a to-do item. And so that's the first thing that we would actually do, is that constructor we had before where you pass in the ID and the title and the is done isn't particularly useful because in order to use this class, you have to know all those things, in which case you've already fetched the data, so what are we doing anyway? But there probably is only one way to fetch a to-do item. In this case, I'm assuming it's stored in Redis. I'm assembling this arbitrary key, and I'm using async await because it fits much better on slides. And so we can introduce this single source of truth for fetching. We can say if you want to fetch a to-do item and you know its ID, call this method, call gen, and we'll take care of fetching it for you. We'll go to Redis, we'll fetch the data, and then we'll return you the to-do item. And we'll even remember one thing, which is a small detail on this slide, but is important if we're going to be duplicating this code in 50 or 100 places, which is that null check. Redis might be down, might return null. That's a possibility. And in that case, we really want to not null pointer exception or whatever the equivalent in JavaScript is. We want to do something graceful. And in particular, we want to only have to remember to do that null check once in this single source of truth. But again, I've kind of dodged the question. We were talking about authorization. How are we going to do authorization? Well, now we have our answer. Because now we have a single source of truth for fetching. We've said the only way to get a to-do item, ideally when we wrote this, we actually would have made the constructor private to this class so that only this gen method could create one. This is the single source of truth for fetching. And so this is a perfect place to put our authorization. We can say, okay, if everyone who's fetching a to-do item, no matter what interface they're using, no matter what storage they're using, is going through this method, then this is where we'll put it. And we'll just add a pretty trivial check can see function, and we'll say if you can see it, we return you a to-do item, and if you can't, you return null. And this pattern works really nicely because it creates the pit of success. Right? The easiest thing to do in order to fetch a to-do item is you call this gen method, and if you called this gen method, we did the correct authorization for you. And if we designed it right, it would actually be really hard. In this example, I can't even think of a way for you to get a to-do item without doing the authorization. And that's exactly the property that we want from authorization. You should not be able to avoid it by accident or because you're trying to do the easiest thing. So now we need to implement this check can see function. We said that our privacy policy here, our authorization logic was a to-do item can only be seen by its creator. So we just need to say the data's creator ID has to be equal to the authenticated user ID. All right, well, that's kind of tricky because we don't actually have the authenticated user ID. So we could take a first stab at this. We could use global variables. Any fans of global variables? Anyone want global variables in their probably most sensitive logic for authorization? Not a lot of global variable fans in the crowd. So we don't want to do that, which means we're going to need to pass this user ID in somehow. And this actually exposes a flaw in the API that we created. We said this is the single source of truth for fetching. You want to generate a to-do item and you want to pass an ID. I claim that's not enough. I claim that this isn't actually the function signature that you want. Because if you're fetching a to-do item and our to-do items have authorization logic behind it, you can't just tell me the ID. You also have to tell me who you are. You have to say, I am this particular viewer and I am trying to fetch this ID. And then and only then can I either say, yes, you can have this to-do item, or no, you're not allowed to see that. And so as soon as we make this change, we pass it down through checkCanC, and it makes checkCanC pretty compelling at this point. It's a function that takes a viewer, and it takes the raw data, and it tells you whether you can see it or not. Now, I'm not a huge testing zealot. I'm not like, every single class and every code base must have at least 3 unit tests. But if there's one piece of code I'm probably going to test in a code base, it's authorization. I want to make sure we cover every single option there. And this checkCanC suddenly is really easy to test. It's just a pure function. Takes a viewer, takes data, and returns true or false. That's a really easy function to write really compelling and easy to read a unit test for. That's not a bad thing here. And so this pattern, this idea that your class would have a gen method on it that would take in a viewer and an ID, this pattern is ubiquitous in Facebook's code base. If you're trying to fetch a user, a page, an event, a group, you name an object on Facebook, there's a class that represents it, and the way that you get it is you call this asynchronous static factory method that will either return to you that item or will say, no, given the viewer that you provided and the item you're trying to fetch, you can't see that thing. And there are no other public constructors, which means you can't just artificially manufacture a to-do item from nowhere. You must have gotten it from gen. And we have this pit of success, where if somebody passes you a to-do item, you know that they've authorized it, because that's the only way to get it. So I was talking about authorization, and the way that we're going to put authorization into the stack, not at the API layer, not at the GraphQL layer, but at this layer below it. And I want to talk a little bit about efficiency. And efficiency is particularly compelling for GraphQL because of its ability to do these deeply nested queries. In this example ends up being very similar to the Slack UI, where we're trying to fetch a piece of information about an object and then something that's connected to it. You can imagine that this would actually be really inefficient if we fetched it naively. Let's assume that we have this fictional Redis log, which is going to log all of the keys that we're fetching. Well, we're going to fetch a logged in user, so that's going to be a get. Then we're going to fetch that person's best friend. That's also going to be a get. And then we'll do some sort of range query, and we'll say, OK, give me the first 5 friends. And then we're going to fetch all of their names, so we'll issue 5 more get queries to the back end. And then we're going to ask for all of their best friends. And at this point, whoever is looking at this log is running over to a desk and saying, what are you trying to do to this database? This is clearly not the most efficient way of doing this round trip. We can even look at the query. And if we look at the query and look at the data fetching we were doing, it looks wrong, because the query itself was nested. Right? That original get and L range, that seemed fine, but we fetched 5 friends at once. Why wouldn't we have just done a multi-get? Why wouldn't we have said, OK, fetch me all 5 of these keys all in one round trip? When we fetch the best friends, that's also sort of in that same almost layer in this tree that we create when parsing the GraphQL query. We would like to do that in a multi-get as well. If we were designing sort of how we would want to fulfill this query, this would really be what we'd want to do. And this arguably makes GraphQL more compelling if we can do it. Because if all of these were different round trips, if these were actually 13 round trips to a resource endpoint, we probably couldn't do this kind of batching. We probably are going to have those 13 hits to our database. So how are we going to go about implementing batching in GraphQL? And given the theme of the talk so far, this next build is probably obvious. We're not. We're not going to build it into GraphQL at all. Instead, we're going to build it into this business logic. Because the batching that I described, the ability to not constantly be hammering your database with single gets, isn't just valuable in GraphQL. GraphQL exposes a lack of it more obviously because it has these deeply nested queries, but if you're building a website or you're building a REST API or any other API, you probably still want this batching behavior. And so one solution, because we're using JavaScript, is to use a package that Facebook's open source called Data Loader. And Data Loader is sort of interesting to me because it was open source maybe a year after GraphQL, but it predates GraphQL at Facebook, the equivalent abstraction, by maybe 3 or 4 years. And it's something that we just sort of assumed was a thing that would exist in systems when we were building GraphQL. We didn't even think about batching because we had Loader under the hood. And so there's a JavaScript port of a concept we already had in our PHP code base that we open sourced. And the key idea behind loader is when we wrote this code, I omitted the authorization so it fit on the slide, but we still have the authorization in there. We've already set ourselves up for failure. Because if we assume that this fictional Redis API we have is going to do a single get when we call redis.get, that's returning a promise, we're already lost. Because we wrote do a single get here. And so there's no clean way for us to batch it instead. Instead, what we'd really like to do is we'd like to say, okay, when we're loading user data, we can do it with a multi-get, where if you give me a list of IDs, this is the multi-get that we run in order to fetch all of them. Do this in one round trip as a multi-get. But then what do we do in our user code? Well, that's what data loader does, is instead of calling the redis.get directly, we construct this data loader with effectively a batch fetching function, and then we use a single fetching function in the actual code itself. And under the hood, what user data loader is doing is it's looking for all of these load calls, it's gathering them all up, and then when the event loop ticks, it says, okay, let me issue all of those out at once. And so with these, 4 lines of code, 4 added, 1 deleted, so 5-line diff, we immediately get this result, just out of the box. So this is helpful. This is good. We've improved things. But now our problem is caching, because I can't actually say that this is the ideal scenario. I don't know if you can see those colors there, but we've actually overfetched here. We fetch user 1, we fetch user 2, we fetch user 5, and then we fetch them again. There's no reason for our server to do that. It could have just cached it on the front end. So how do we do that? And this is where I have to reveal that I did lie to you just now. With that 5-line diff, what we just did, we actually get it out of the box. Data loader caches based on IDs. So if we looked at the real logging here, if we didn't disable caching within data loader, we would actually see this. We wouldn't have fetched them again, because whenever it gets that list of IDs it's trying to fetch, it goes, that ID, I've already fetched it. I'm just going to return to you that exact same promise for you to resolve. And so this pattern, this idea that we should have an abstraction layer below sort of this canonical representation of an object, so certainly below GraphQL, below our APIs, that can take care of batching, this has proved really valuable and really flexible as we're building out these object models at Facebook. So that solved caching, I guess. But did it? Because this doesn't help our clients at all. And this is a really common question with GraphQL, because if you're using a traditional REST API where a resource has a URL, caching is just synonymous with HTTP caching. You fetch this URL, you go to fetch it again, cache it. But what do you do in GraphQL when that query fetched what? It fetched a user, his best friend, fetched 13 different users. How do we know what to cache? Well, really what we want on this object is we want some sort of identifier. We want a thing that we can use as a cache key. And so we should just add that. We'll say, okay, get ID, there's some ID associated with it. And then in GraphQL, this is using GraphQL.js in order to expose a user type. We're going to say there's now a new field called ID of type ID, and it's trivial to resolve. And then on the client side, when we issued a query like this, we would ask for the ID of the user and the ID of the profile photo, and we would get this back. Apparently, I just started up this SQL database and I'm auto-incrementing. So this is both user ID 1 and photo ID 1, and we're done, and our clients are happy. Yeah, they're kind of happy. I don't know. They're not that happy, because they're looking at this and saying, well, what am I supposed to do with this 1? I'm going to throw the user in with cache key 1, and then I'm going to throw the photo in with cache key 1. I guess I could know that they're different types. You can ask GraphQL that for the type name, but that sounds like a lot of work. And so I'd argue that this isn't actually what we want from IDs, and that there are really 3 properties that we want from IDs. The one that I've been describing, this idea of a unique cache key, is valuable, but I actually don't think it's strong enough. I think what we want from IDs is we want them to be globally unique across the system. And this is something that if you've used UUIDs or if you've used 64-bits IDs and done the math that you'll run out of them when the universe explodes, you've already gotten used to, which it's really nice to have a single identifier that unambiguously represents an object. You can log it. And when you log in, you're like, oh, I wonder what thing didn't load. It's not like, well, something with ID 1 didn't load. I'm not sure what. You're just like, okay, that particular thing did not load. Having them be globally unique is really valuable. The second thing that we really want IDs for is a refetch identifier. If I've already fetched the user with ID 1 once, it's kind of nice to be able to go back to the server and say, hey, remember that user I fetched before? I'd like to refetch it. You know, they just pulled the refresh, they just hit F5. That would be really valuable. And a third thing that I think we often associate with IDs is client comprehension. It was sort of interesting that we could see those numbers, that 1 and 1, and I almost made a joke about it. They're like, oh, clearly we're using SQL and we're auto-incrementing and it just started. But is that something that we really want our clients to be able to do? Well, they certainly don't need to do it for a global unique cache key. You don't need to know what that key is. It's a string used as the key. For the refetch identifier, you need to know even less. It's just an opaque token that we've passed to you and you can pass back up to us. And I would argue that the client comprehension part can actually be really harmful. Because what's the worst case here? We just assumed, I just convinced everyone, that we were using auto-increment IDs in SQL. So those IDs were probably numbers, right? They're probably ints. I'm going to cast them to int and use them in some way. Or I'm going to scrape the entire system by just going 1 to n until I start running out of things. But if the backend wanted to switch, the backend says, we're tired of using auto-increment in SQL. We're now going to assign a unique UUID to every single item and start passing that down as the ID. Our client was probably casting that to int before, and we're not going to be able to do that. We've actually restricted our ability to update our backend, to update our API, because the client was able to understand these IDs. And so if we don't need them for those first two pieces of functionality, the things that we really want from IDs, and it's harmful to have the refetch identifiers be something that the client can understand, that they can reason about, then why not make them opaque to clients? Why not preserve some option value for us as we're designing the API, as we're potentially changing backends? So this is the part of the talk where I get to do the embarrassing, you won't believe this is actually what we do internally, but it is, which is we have these user IDs. These user IDs, they are actually FB IDs, they're 64-bit IDs, so they're unique. But in cases where they might not be, just to make sure that they are globally unique, we append the type : and base64 encode it. Completely undetectable, completely irreversible base64 encoding. But in all seriousness, if you look at a GraphQL response from Facebook server, it'll look a little bit like this. You're gonna have these mangled IDs, they all have the equal signs at the end that are the telltale sign that you've been using base64 encoding, and this is kinda ugly, right? This is not as pretty as the previous slide, but what did we want the IDs for? These are certainly better cache keys, right? Because now they're not colliding with each other. These are actually better refetch identifiers, because if you just send me one of those IDs on the server, I will use my state-of-the-art decryption and on base64 encode it, find that it was the user with ID 1, and now I know exactly what to fetch. And the fact that you can't understand these means you're probably not on the client going to cast them to int and restrict what I can do in the future. It's a little uglier, but it's arguably a lot better in the functionality that we want. So that was answering a bunch of common questions about how we build APIs in the context of Facebook's GraphQL stack. We think in terms of graphs, not endpoints, because thinking about the objects themselves proves compelling as clients are constantly evolving. We strive to have a single source of truth. We really want to have, for each of these objects in our graph, a single representation on our server that we can rely on, because that's a place where we can put logic that we want to be duplicated no matter what backend we're using or no matter what API we're using. And we want to have a thin API layer, because while we're using GraphQL across the board now, we weren't 5 years ago, we certainly weren't 10 years ago, and who knows in 5, 10 years what we're going to be using. And so having this API layer be thin means all of the really critical logic, the business important logic, lives in a layer underneath it that we can reuse. Thank you.